Hi everyone, welcome back to Conquering Math, where it all adds up. I'm Pat Long, and this is problem of the day number 4, the spring fundraiser. So today we'll be looking at the problem that I posted at the end of the last video. Your class is making spring seasonal baskets to sell as a fundraiser for end of the year events. You have 90 mini Fresh Breeze scented candles, 45 bags of trail mix, and 60 tickets to a minor league baseball game. What is the maximum number of baskets you can make so that each basket is identical and there are no supplies left over? How many items will be in each basket? And explain. Okay, so for this example, we want to make sure that we are making a whole bunch of baskets, but that everyone who purchases a basket gets the same thing. We don't want to just randomly insert items into the basket. So the way that we can figure this out is by finding the greatest common factor of the three items that we have. So we have 90 candles, 45 bags of trail mix, and 60 baseball tickets. So we need to find the greatest common factor of 90, 45, and 60. There are plenty of ways to do this. My favorite way I'm going to show you now, I like to make a little list. So here what I've done is I've created a table for each of the three numbers. And so what I'll do is I'll walk you through step by step what to do for 90, and then you should get the idea by the time we're done with that, and we'll fill in 45 and 60. Okay, so now that we have the table set up, we need to fill them in with factor pairs. This is the most efficient way to find all the factors without skipping any. So what I do is I try and think of, I go in order starting with 1, and we know that 1 always works. And you do the number you started with. So like we're starting with 90, so you do 90 divided by 1 is 90, so that's your factor pair. Then you try 2, 90 divided by 2, and you can use a calculator to do this. 90 divided by 2 is 45, so that's our factor pair. 90 divided by 3 is 30, so again, another factor pair. Now when you do 90 divided by 4, you'll get a decimal. If you get a decimal, that means that the number that you plugged in was not a factor, so you don't list it. So that brings us to 90 divided by 5, which gives us 18. 90 divided by 6 gives us 15. 90 divided by 7 and 90 divided by 8 both give us decimals, so those don't work. And then 90 divided by 9 gives us 10, so we have 9 times 10 as a factor pair. The next number would be 10, and since we already have it on our list, we know that we found all the factors and we're done. So I went ahead and I listed them all out. So we have 1 times 90, 2 times 45, 3 times 30, 5 times 18, 6 times 15, and 9 times 10. And my favorite part about doing this is if we list them as pairs, once we find the number of baskets we can make, it'll also tell us how many of each item are in the basket. So I went ahead and filled in the charts for the next two. So for 45, we have 1 and 45, 3 and 15, and 5 and 9 as factors. And then for 60, the factor pairs are 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, and 6 times 10. Okay, so now we have all these factor pairs, and we are looking for the greatest common factor. Now, if we only had 2 numbers that we were dealing with, this would be pretty simple. But since we have 3, what we want to do is we want to pick a list and go through and make sure that those factors appear in all of the other lists. Now, you could underline all of the common factors, but since we want the greatest one, my suggestion is to start with the biggest number and work your way backwards. And since 45 has the least number of pairs, I'll start with that. So if I look here, we have 45, so I'll go compare it to 90, and sure enough, there's 45. Okay, so we're on a roll here. But if we go over to 60, we notice that 45 is not a factor of 60, so that's not going to work for us. So I'm going to go ahead and just cross that off. That doesn't really help. All right, let's take a look at 15. 15 is a factor of 45. If I go over here to 90, I also see 15. And if I go over here to 60, I also see 15. So that means that that's our greatest common factor. So I'm going to go ahead and circle that for each of them. And you always want to go back and double check your work. So just, take a quick look through. The other factors of 45 are 9, which we do see repeated over here in 90, but not in 6. We see 5, which is actually a factor of all of them, but that's less than 15, so it doesn't help us. And same with 3 and 1. So we've checked our work. We know that 15 is the greatest common factor. So that means that we can make 15 baskets. Now, if you hadn't done it this way, what you'd do now is you'd say, okay, 90 candles divided by 15 baskets. How many candles? 45 bags of trail mix divided by 15 baskets. How many bags of trail mix? And the same with the tickets. Here's the thing though, since we did it as factor pairs, this is our answer for that second piece. There we go. So we know that if we have 15 baskets, we will have 6 scented candles in each basket. We will have 3 bags of trail mix in each basket, and we will have 4 tickets to a minor league baseball game in each basket. So what I said was the greatest common factor of 90, 45, and 60 is 15. So we can make 15 identical baskets with no supplies left over. This means that each basket will contain 6 mini candles, 3 bags of trail mix, and 4 baseball tickets. And that's it, you're done. So Pat, what about the total cost? You said for extra fun we could calculate that. Yeah, I did, but since that's a bonus problem, I'll let you figure that one out. If you're not sure what to do, estimate an item price that you think for each of the items, multiply it by the number of that item in the basket, and then add those 3 costs together, and that will give you the total cost for the basket. And then, once you've done that, you can figure out, well, if I sell 15 baskets at that price, how much money would the school make? So that brings us to our problem for the next video. Problem of the day number 5 is about fish tank weight. So it says Tessa buys a brand new fish tank with dimensions 36 inches by 18 inches by 16 inches. The tank weighs 58 pounds when empty. Tessa wants to put the fish tank on a table that can hold up to 150 pounds. Will the table be able to hold the fish tank when it is full of water, or should Tessa find a different spot for the fish tank? And just to help you out, I told you that water weighs approximately 0.036 pounds per cubic inch, also known as 36 1,000ths of a pound per cubic inch. So thank you for joining me today for this episode of Problem of the Day on Conquering Math, where it all adds up. I'm Pat Long, and I'll see you next time.